Good morning. All right, today at my house we decided it is pajama day at school. So I'm here today for you in my onesie because it's that kind of dark day and we have a chain of those going on, I feel like. All right, the point of today's lesson is going to be to talk about where we use converging lenses, some of the devices or things we have commonly around us that take advantage of the properties of these lenses and how they work. So let's get started. You've got your note paper ready, hopefully. And today we're going to call this, let's call this, actually I think I use a pen so it shows up a bit brighter. It's kind of dark in here today, like I said. Converging lenses. There you go, little elephant over there. Converging lenses and their applications, which is going to mean for our purposes what we use them and how we take advantage of their properties. So I'm not going to spend too much time reviewing converging lenses today and going over the ray diagrams you did the other day. They're going to come up in the course of our discussion. So you're going to see me take those concepts of using rays of light and determining what kind of image you get actually in play today within these things I'm going to talk about. So let's do them one at a time. We're going to start with the camera. Okay. And so just to do like a little diagram of a general idea of how a camera works, you have, let's do the shape here from the side. So you have this area, and then at the end here, there is a lens that you cover up, usually when the camera's not in use. And that's a converging lens. So it has that shape we've talked about. When light rays hit it, they converge towards a focal point. And then back from here, this doesn't really matter what the shape of this looks like. You know, I'm no artist. This would be the rest of the camera. So in the old days, there would actually be like a film that would be back here in the back of the camera. I should have brought down one of my old cameras. I have a couple I've kept forever. And like one I had like from grade 7, for example, you would load actual film in it. So you open the back and then your film would come all rolled up in a canister, and you'd pull a little bit of it out, lay it down. It would catch this like gear that would wind it, and then that would start bringing the film out. And each time you took a picture, the film would advance inside the camera, and the part that had just got a picture would roll back into the container, and then a new piece would be exposed. Then you take a picture and it would gear forward and wind that. The light would hit the film. So the light would come in and hit the film at the back of the camera here. And then that would sort of create the exposure that would give you your picture. If at any time you open the back of your camera while you had the film in there, it would ruin all your pictures. It would expose them to light and ruin that. So that's a bit of how cameras used to work. Now it's all digital, pretty much. So most of the cameras you're working with, there's not like a film here to capture the image on. There's some sort of sensor back there that would pick up on the light and then store it as an image instead of having it actually be on a piece of film that you develop later. All right, so here's kind of what's important. The lens right here at the front of the camera. And then I'm going to call this film for now, even though it can be digital as well. So the object is somewhere out here in the world. And then you need enough light to pick up on that object and then imprint the image on the film. So there's a couple other pieces to the camera as well. One of them is called the aperture, and that determines sort of like the pupil of your eye, how much light comes in so that you don't overexpose, which means you wash out the picture because there's just too much light altogether, or it's not too dark. And so also the flash can help with that as well, to light up the area to make sure enough light rays get in to sort of be picked up by the sensor of the film. Okay, so all that is really kind of extra. To get into what we talked about with what this lens can do, you have your object out here somewhere, the thing you want to take a picture of. And how this works is the light rays come in. So I'm just going to draw a light ray here. And then this lens has a focal point, which means that like if this is like, let's say F here, okay, that ray will go in there. And then, so if I had another light ray from a different part of the object, let's say here, we know it's converging, so it's going to come here, and we get that upside down image over here. So the image lands on the film. Those rays are traveling through the focal point. And so that's the benefit of the converging lens. So on the film, the image is actually upside down, like we talked about the other day. A couple things about this, which you'll see with the images. The image is going to be smaller than the original object in most of the cases we're looking at, and it's going to be inverted, which means upside down. This is really similar to your eye, okay? Same idea. So you have the lens here, and then you have the screen or the thing you can put here to get your real image. So it's smaller, it's inverted, and it's real in terms of its location. It is behind the lens, and then we don't need to worry right now about describing where it is in relation to F, but you can see it is past F where it's landing. Okay. It is possible. There are features on your camera to adjust where the lens is. You can also, some of you might have cameras, or your parents might have cameras where you can change the lens. So you can put bigger ones on to do some more unique things with the light and all those more expensive pieces of glass that are engineered to have additional features and give you more range with your camera and things like that. But in general, that's how it works. One lens at the front, it brings the light rays in to converge at a focal point. They cross, and then you get the upside down image of whatever you're looking at over here on the film. And it's real because it's actually captured on that either actual film or a sensor. Okay, projectors work in a similar type of way. So you have, if we think of like in a movie theater, let's do that. You have the object. I'm going to draw this. In this case, it's film, because the movie shows up to the theater on these like big wound up spools of like metal spools, I think still. I don't know if any of you work in a movie theater. Anyway, the lens for the projector would be here, and it's a converging lens. I put here, projector lens. It's possible some of you might even have a projector in your house that you use. Or even the ones we use at school, if you think of that in the ceiling, okay? It's not actual film we're loading in there. They're getting a signal. It's all digital again. But whatever that object is, it gets projected through the lens and then onto the screen or smartboard that we have at the front of the room. So the light rays are going to come from the object. Okay, so there's a light in the machine usually, well, always. And then when they hit the converging lens, like last time, there's a focal point somewhere out here. And they usually have a quite large screen over here. Right, screen. Movie theater, obviously they're really, really large. In our classroom, think of a smartboard or something like that. And then the light rays are going to have a converging point. Okay. I can do this. I'll do another one like that down from the bottom. We're just through F, let's say. And we get our image over here. Okay. So once again, the image, this time it's larger, usually. That's the point of the projector. It is inverted, and it's real because it's captured on the screen. Its location to F is it's after F. I don't know if it's 2F or 3F or 4F or larger, but let's just say it is after F. on the opposite side of the lens as the object. Now it's upside down, but this is why I talked about the other day how they load the film upside down. So if you loaded the film right side up, it would show upside down on the screen. So you have to know to put it in upside down so it shows right side up over here. Right. So the next one, I'm just giving myself more space here, going back to the top of the page, is going to be the magnifying glass or lens. All right, so this one, we're going to draw like these handheld pieces of glass here. Maybe too big, but that's okay. So it's a converging lens. And then we're going to have some small little thing here, like let's say a little piece of paper with a 1 on it. All right. Now I'm going to have, let's do a line from the top of my object here, come in, and then head towards F on the other side, wherever that is. Okay. And then I'm going to do another one where it sort of would head, let's say, towards the optical center, and then keep going. So in this case, what's going to happen is these ones are never going to meet. So then I need to trace backwards to find where the lines cross, maybe somewhere back here. And that would make for a larger image than what I had originally. So this is my object, and this is my image. And so the image this time is larger. It is upright because it looks the same as the object, and it is virtual. In terms of its location, it's the same side of the lens as the original object, but we can't actually capture it on a screen. Okay, and that's how these work to take something that's small and make it larger for us to look at. Okay. All right, the next two things I'm going to talk about have two lenses in a system. So the microscope and the telescope. So the microscope, if you remember using one of these, most of them that you've used sort of have this look to them. So we have a lens up here, which you call the eyepiece. And then you have the nose piece on your microscope. And then you usually have three options: low, medium, and high power objective lenses. So each of these has a lens on it, and there's only one at a time. So you click them around to put them in different places. And so here you'd have like your stage, and then under here, there'd be a light. And your object is on a slide on that stage. So the light shines below, it goes through the object, and then it travels through two lenses. Okay, it travels through whichever one you've got clicked in here on the nose piece, and then it travels through this one. So this makes for kind of doing a couple layers of this, kind of adding what we had on the first side, like a camera or a projector, and then magnifying it for the second level. So the first lens I'm going to put here acts like what happens in the camera or your eye or the projector, all those situations where it flips it and puts it upside down. And you'd be familiar with this if you worked with a microscope, because you know if you're looking at something on the slide, if you move it away from you, it looks like it's coming towards you away. Move it to the right, it moves to the left in the eyepiece, left to the right. So those kind of backward scenarios. So if you think about that for a second, it makes sense that in this system of using glasses, pieces of glass, that it is going to invert and make it upside down. But then it makes it bigger than it is. That's the whole point of the microscope. So then it's doing this piece as well. So the second lens acts like a magnifying glass to enlarge it. Sorry, my writing looks particularly messy today. Okay, telescope is kind of the same thing. I'm going to draw that, and then I'm going to do the ray diagrams that go with it here. Okay, so the telescope, not all of them, there's different kinds of telescopes. There's different kind of microscopes too, actually. But the one we're talking about, the glass pieces, these ones, the refracting ones, they have like typically, let's draw it really simply here. Okay, there tends to be a lens right here that's converging, and another lens here that is also converging. So we have the two systems again. So you're looking at this faraway object in space out here. The light is traveling from there. It goes through this lens and then through the other lens, and we have a similar thing. The first one is going to do that inversion piece, and then the next one is going to magnify it. So remember, you're looking at things that are very far away. So even though they're really, really large, wherever they are, the piece of light is quite small. And so it's, say you're looking at a planet, it's very, very tiny, and this magnifies that so that you can see it better. Okay. There's a whole bunch of stuff here we could talk about in terms of when these things were invented and how they altered our perspective on the world and things like that, which I would love to talk about, and maybe we'll come back to on Friday. Okay, what these things have done in terms of changing our perspectives on things and moving things forward or changing where we were at. Okay, so this part is going to be pretty complicated because I'm going to show you what happens through the two lenses, and then I'm going to call it quits on the video today. So I'm going to put a principal axis here. Okay, and then I'm going to start with my first converging lens right here. And I'm going to say that the focal point there, the same thing over here. Now, the object, I'm going to use an arrow because they're just easy to draw, is going to be this small object over here. So I'm going to use the top of it. I'm going to use 2 light rays to find the image. I should have a ruler. Okay, don't. So I'm going to make my first light ray come down through the focal point till it hits the lens. Okay, and then you might remember that these ones are the ones that then turn and go parallel. Okay, like that. Second light ray I'm going to use is going to go through the optical center, the ones that continue to go straight. So I'm going to bring that. Okay, and it goes like that. So my image has shown up right here, and I can see that it doesn't look too different in size right now from the one I've done, but it's inverted, upside down. Okay, so then there's another lens, and so I'm going to put one in place. And once again, the focal point for this one, I'll just keep it there for simplicity's sake and try and do another one on this side. It could have its own focal points, but I feel like this might actually work to just leave it like that. And so for this one, what's going to happen, I'm going to show the light rays continuing to come off of this. And this one's going to head toward, I'm going to make this one head towards the optical center. The light rays are still coming up from the bottom. My image is now my next object for the next piece of glass. And then I'm going to do the one, because I'm inside F, where it goes straight. And then it turns and goes towards F on the other side. So these two are not going to meet. So the point of this is I'm going to have to draw these lines back to where cross, which is just on the edge of my page. And then I get this really large image here compared to my original object. So that is like probably beyond, well, I was going to say it's beyond what you need to understand about ray diagrams. If you get this and follow this, that's amazing. Typically in school, I would leave this sort of like as a challenge to see if you could get this on your own. But I'm putting it here as an extension for those of you that might appreciate it or are curious or want to know about those two lens systems. So just to review it, and then I'm going to shut down the video for today. You start with this original object, whatever it might be, whether it's on your slide or if it's a planet or something like that out in space. And then the light rays come from behind or the actual object itself. They go through the first lens to make this inverted image, which is still quite small. And then those light rays now keep going, and the image becomes the object for the next piece of glass. But these light rays are not going to converge. They're going to have to be brought backwards so that you get this virtual larger image of what you just had. Okay. All right. That is going to be what I call a day on that one. And you'll see the other things I've put together to complete the lesson. All right. Take care. And I will hopefully talk to you either tomorrow or Friday.